The energy trap, a concept discussed by UCSD professor Tom Murphy, describes the challenging situation that arises when societies need to invest a lot of energy into new renewable infrastructures, just as fossil fuels become scarce and expensive. This problem emerges because building renewable energy systems, such as solar panels and wind turbines, demands high upfront energy inputs. When the energy supply is tight and costs are rising, it becomes tricky for governments and businesses to invest in these solutions after fossil fuels start to run out. Ideally, societies should begin transitioning to renewable energy sources early, when the energy supply is still sufficient, to prevent further disruptions. A clear example of the energy trap can be seen in how countries, including Germany, have approached renewable energy transitions. Germany has been proactive in investing in renewable energy long before facing a dire fossil fuel shortage. Initiatives such as the Energiewende, which started decades ago, reflect early action using available energy from fossil fuels to build new infrastructure. This kind of forward thinking helps to mitigate the impact of fossil fuel shortages. By investing in solar and wind energy while fossil fuels are still available, Germany avoids a severe energy crisis later. Their experience illustrates that acting early rather than waiting for constraints to tighten is crucial. Exploring the energy trap ties into broader topics concerning sustainability and information technology. Transitioning to renewable energy is essential for decreasing carbon output and addressing the climate crisis. The challenge becomes more nuanced when considering land use for renewable infrastructure, which requires balancing energy needs with habitat preservation for other species. Smart grid technologies offer partial solutions by optimizing energy distribution and storage, making renewable sources more efficient despite their intermittent nature. Murphy's energy trap concept helps show why early action matters. The longer societies wait, the more energy constrained the transition becomes, potentially limiting our capacity to maintain both technological systems and ecological health. The energy trap challenges nations to wisely manage energy investments while dealing with existing technological infrastructures. A tangible example of dealing with this is found in Denmark's approach to wind energy. During the 1970s oil crisis, the Danish population faced energy constraints that spurred innovation in wind turbine technology. By channeling resources into advancing wind energy while still having access to fossil fuels, the country not only created a robust renewable energy sector, but also became a leader in wind turbine manufacturing. This has been instrumental in their ability to nearly meet their electricity demand through wind power, reducing their dependency on fossil fuels and positioning the nation as a model for renewable technology. When considering the energy trap alongside technology interests, several aspects emerge. First, research into battery storage technologies is crucial because they can store energy during production peaks and provide it during demand peaks, balancing fluctuations in supply inherent to renewable sources such as wind and solar. Second, the development of energy-efficient computing systems can help manage the enormous data processing demands that come with managing energy grids reliant on unpredictable renewable sources. Third, integrating existing technologies with new renewable systems through innovations in smart grids can enhance overall efficiency. Such efforts are paramount in aligning technological progress with the goal of achieving a sustainable future.